Okay, sum and difference of cubes, plus and minus perfect cubes. Different from yesterday because you can do plus and minus. So this is just to help you remember your formulas. Square, multiply, square. This is the second part of your answer. Square, multiply, square. And then same, opposite, always positive is to help you remember your signs. So if it's plus, your answer has the same sign, opposite sign, always positive. Minus, same sign, opposite sign, always positive. Okay, so if you look at number 1, I already got started. It's just like yesterday, or a difference of squares. So you're writing it as something cubed plus something cubed. X cubed is x cubed, 3 cubed is 27. You don't have to remember your cubes. That second column is your cubes, yes? Okay, so 27 is 3 cubed. So what is A? X. And what is B? See what I mean is it's a very, very similar from what we did yesterday. Okay, in that aspect. So the different part is your formula for your answer. So this was the sum of cubes. We found our A cubed plus B cubed. So now we just need to plug our A and B into our formula. Okay, so we're going to plug it in. And we're going to ignore this. Don't let this piece throw you off. The only thing you are looking at is your A and B. Yes? So A plus B is your first set of parentheses. So X plus 3. Now, it's going to seem a little unnecessary what I'm about to do, but when I get to number 2 and 3, you're going to understand why I do it. Okay? So in parentheses, we're going to put our A, and we're going to square it. Now we need to do the opposite sign, minus A times B, which is X times 3. Always positive sign, B squared. So 3 squared. Okay, and then we simplify. So I know this step may seem a little silly on this problem because it's simple, but when I get to the next two, you're going to see why it's important. So I'm just going to bring it down, X plus 3. X squared is just X squared. What's X times 3? And then bring down my plus. And what's 3 squared? 9. So like I said, those would have been super easy to simplify just as we went. But when you get to problems that have numbers and letters or different exponents, that makes it a little harder. Any questions with that one? Okay, so let's look at number 2. Okay, number 2. Okay, this one is a perfect cube minus a perfect cube. Does it have a GCF? Okay, if you're unsure, y'all, always check. So math right 9, 64, 125. It gives me a 1, therefore there is no GCF, so we're good. Is it in order? Degree of 3, degree of 3. So we don't need to change anything. You'd be wasting your time. So we're just going to go right in and figure out what cubed minus what cubed. So this is difference of cubes. So that's the other formula. What cubed gives me 64? And then m cubed is m cubed. Okay, what cubed gives me 125? And then n cubed is n cubed. Now, I know it has a minus in the middle, and a lot of time I tell you that means negative, but we're just going to ignore that because all that plus and minus in the middle is telling us to do is which formula. Okay, so don't think, oh, that's -5. Don't do that. Yes? Okay, ignore the plus or minus in the middle. That just tells you which formula to pick. So this is going to be the difference of cubes, which is top right. Bless you. So what is A? For what? Yes. And what is B? So again, we're going to ignore all that, and we're only using this now to find our answer. So now we're using difference of cubes, which starts with A minus B. So 4m minus 5n. And then I open the next set of parentheses, and I do A squared, and I'm going to use parentheses. 4m squared plus, this is the opposite, A times B, so 4m times 5n. Always positive, b, so 5n squared. So all I've done is plug in my formula, yes? Everybody okay with that? And now we're going to simplify. My first parentheses doesn't simplify. Okay? Now, when you have a coefficient and a variable inside parentheses with an exponent on the outside, you have to give the exponent to both. Now, on number 1, you just had a variable, so you just gave the exponent to the variable. But here you have both, so they both get the squared. So what's 4 squared? 16. And then m squared is just m squared. So that's where a lot of people make a mistake, which is why I do this step. Okay? A lot of people will write 4m squared and move on. That's not the answer. Okay? It's 16m squared. What's 4 times 5? And then you write your letters in alphabetical order, so m, n, plus, what's 5 squared? And then n squared. So that is your answer. Now, technically, you have a trinomial after your binomial. It's not factorable, okay? They're a prime. So you don't have to keep going, okay? Okay, let's look at number 3. Any questions with 1 and 2? Okay, number 3 is kind of a lot. It has a lot of things, but there aren't really any on your practices quite to this extent. Okay, what's wrong with it right away? It's out of order. How do I put it in the proper order? But what's it going to look like when I get the proper order? Negative 343 c to the 9th plus 8a to the 6th, because that was negative and this 8 was positive, so they have to stay that way. However, are we allowed to have a negative in front? No. Is there a GCF other than the negative? If we're unsure, what should we check? 343, 8. So it's 1, so no. So what is the only thing we have to take out? The negative. So I'm going to take out the negative. And what that does is it just makes both of their signs opposite. Okay? Or you could divide by -1, which also does the same thing. So it's the same thing as saying divide by -1, divide by -1. So I'm going to bring that negative down here so I don't forget about it, because that's technically my GCF. It's a part of my answer. Yes? Okay. And now I need to write this as something cubed minus something cubed. What else do you notice is different about this one from the other two? My exponents. Okay, what about them? They're bigger than 3. Now, is 3 a factor of them?
Yes.
Yes, so they are perfect cubes. Okay, as long as 3 is a factor of them, they're perfect cubes. Now, the way you figure out what goes in your parentheses, yesterday we cut it in half because we were doing squares. Well, cutting in half, isn't that the same as dividing by 2? So with cubes, what do you think we do? Divide by 3. Okay, so what's 9 divided by 3? 3. And now what's 343? Well, what cubed gives me 343? 7. Sorry, I kind of skipped the number. Okay, and then if we did the math, 7 cubed is 343. 3 times 3 is 9. Because remember, power to a power means multiply. So I did not change anything mathematically. What cubed gives me 8? And then what's 6 divided by 3? 2. So what is my A and what is my B? 7c cubed and 2a squared. Now, the only time you're going to have exponents with your variables in your answer is when your exponents are bigger than 3. Does that make sense? But if your exponent is 3, you should never have exponents with your variables other than 1. Okay, so let's get started. Is this difference or sum? Difference. So I'm going to follow the difference, which is a minus b. So 7c cubed minus 2a squared. Now what? A squared. So 7c cubed squared plus, because that's my opposite sign, a times b, 7c cubed times 2a squared. I'm running out of space, so I'm squeezing it. So plus my b, so 2a squared squared. Ah, we made it work. Any questions with what I plugged in where? Okay, so the cool thing is that front one never simplifies.
Where's that last one to?
It's just your 2a squared squared. Okay, what is 7 squared?
49.
And then power to a power means we multiply. What's 3 times 2?
6.
What's 7 times 2? Not plus.
No, 7 times.
Yes. And then you put your letters alphabetical, so a squared c cubed. Plus, what's 2 squared? 4. And then 2 times 2 is 4. So that one has a lot, but it has like all the things. You had to reorganize it. You had to take out a negative GCF. You had variables bigger than 3. You had letters and coefficients on both pieces. So it was a lot, but it's not that bad. Okay, don't skip this step. If you're skipping this step and you're getting them wrong, I'm just going to tell you it's wrong and send you back. Okay, I'm going to tell you to do that step, and then we'll talk. Okay? This one, where you're plugging it in with the parentheses. Like, don't try to go from here to your answer, because that's where a lot of people make all their mistakes. Okay, last one. This one's a quick one. Is it in order? Does it have a GCF? Okay, so we're going to divide both of them by the GCF. What's my GCF? 8. And I'm going to take that out. And what's left? 2x cubed plus 1. Now, is that a perfect cube plus a perfect cube? No, why not? What's not a perfect cube? The 1 is. 2 is not. So look at your paper. I know there's not 1 on here, but y'all, 1 is a perfect everything. 1 to the 4th power equals 1. 1 to the 5th power equals 1. 1 to the 6th power equals 1. 1 is a perfect everything. But is there 2 in the bolded column? No. So 2 is not a perfect cube. So the inside of this is prime. However, is my final answer prime? No. Why? Yeah, because I took out a GCF other than 1. Y'all, prime means you could only take out a 1. I took out 8. So this is my answer. It was just a GCF only problem. And that's okay. The reason I wanted to show y'all this is because I saw a lot of mistakes yesterday. I'm glad I had this on there. Yesterday where people took out the wrong GCF and they'd have like 20, or not 25, they'd have like 50, and they were like trying to make it a perfect square. 50 is not a perfect square, okay? If it's not a perfect cube, that's okay. Be done. Yes? If it's not a perfect square, that's okay. Be done. Yes? Now, if it had a GCF, make sure you take that out first, and make sure you take out the correct one before you decide. Yes? Cool. So this is what you're working on. You have 12 problems. You'll have time today and Monday.